We're actually gonna move on from Taylor and Maclaurin series. I finished talking about series in general. And we're gonna go back to integration and we're gonna talk about applications of integration. That's the next chapter. So to start with, we're doing 6.1, which is about areas between curves. Okay, so let's say I start with a function. We have y equals f of x, and I'm going to give you a picture to think of when you think of this function. So let's say it looks like, I don't know, something like this. And let's say you want to calculate the area from x equals a to x equals b. So if I draw dotted lines up, I want to calculate this area right here. So the way we calculate this area is through, you could use Riemann sums to approximate, use rectangles, take the limit. As you take more and more rectangles, it gives you a better approximate. So the idea I'm reaching is the definite integral. So to find this area of this region, let me call that A. The area is going to be the integral from A to B of our function to get that area, okay? So the area underneath the curve, you integrate, and you have bounds on your integral from A to B. So what we're moving towards now is, let's say I have a picture, I have two functions. So let me do, say I have two functions here, a function, let's say this is my function y equals f of x, and then I have another function, let's say, looks like this, and this bottom one is going to be y equals g of x. And I want the area as between these two functions, between these curves. So I would like this region in between them. That's the region that I want. So the way you get the area in this case, what you can do is you can find the area under the function on top, y equals f of x. So maybe I need some boundaries here between a and b. That's my boundaries. But if I find the area under f of x from a to b, what have I done? I found this area, but remember I do a dotted line up. I've also found this red area too. And that's not what I wanted. I only wanted the blue area. So think of it like you're counting. You've over-counted, and so you need to undo your over-counting. And so I'm going to subtract by, so minus, and then this red part, this is just the area under my function g of x, minus area under okay, and that's going to take away that area that you counted in red, and it's just going to leave us the blue area. So now we know how to find, so let me let me write this with some symbols. The area under f of x, we said that's the definite integral from a to b. Oh, sorry, f of x. I should just say f of x, sorry. F of x. That's the area under f of x from a to b. And I'm going to subtract the area under g of x. These are definite integrals and they have the same bounds of integration, the same numbers on them, a to b. So I can actually combine them together into a single integral. The integral from a to b of f of x minus g of x. And this is how we're going to compute area between two curves, is this formula right here. The bounds from a to b, your top function minus your bottom function, dx. Okay? So let me put that in a overall statement. The area A of the region bounded by curves y equals f of x, y equals g of x equals a, and x equals b is exactly the formula I just wrote down. A is the integral from a to b, f of x minus g of x dx. Okay, so this is how we're going to find area between two curves or between two functions.